All right, so how is everybody doing? Are there any questions? So hopefully PA3 is under control. I will post PA4 later today. I'm still deciding, but I'm leaning towards making it a group project. So letting people work in groups of 2 or 3 or individually. And PA4 will be dealing with graphics, as well as all the things that go along with graphics, like event-driven programming, which is really what we're heading towards with Swing. Writing code that is basically handling software versions of interrupts, right? So code that mostly doesn't do anything, but once in a while wakes up in response to an event and then does something. This is fundamentally different from procedural code. The code we write in C usually says do this, do that, check this condition, and either do A or B, right? Event-driven code really says do nothing. Let's just sit here in a loop and let's just, twiddle our thumbs. But we've set things up so that if, for example, someone clicks a mouse, something happens, right? And when that event occurs, we go off and we execute some code, and then we go back to doing nothing. Okay? If you've done 270, this was your interrupt code with the lights that blink. And every 2 seconds, the next light blinks. And when an interrupt occurs, something has to happen, but then you go back to where you were, right? And this is how most modern code is written. I mean, most of the code you're likely to be dealing with, right? Say for, an Android app or something like that. It's mostly interrupt driven. It's event based. So that's what PA4 is going to be all about. You're going to be implementing a game. So let me fire up Eclipse. And I want to start today by talking about graphics. Okay, and you're going to be doing some drawing in your PA4. You're going to be making things visible on the screen, and we have to talk about how that happens. And that's also kind of fundamentally different from the code we're used to writing in C, for example. In C, if we wanted to, or in Bash, if we wanted to create a widget, we just said, call this Zenity command with these magic options, and there's a window, right? Or if we wanted to draw a line using a lot of graphics packages, we would just say draw a line between here and there, and a line appears. Okay, we don't get to do that in Swing. Painting, doing graphics in Swing is very different. So let me give you some code and show you how this works, and then we'll develop the details. So let me call this drawing, and I'm going to get rid of some of these old projects because inevitably I end up with like 50 files in here. Alright, so we'll make a class called drawing. I'm going to make a new JFrame, and I'll call it main. Alright, there's our JFrame. We can run it. We just get an empty pane. Let's do some drawing in here. Okay, let's make some objects appear. So the main class we're going to work with is graphics. Okay, and you can read about this. If you look online, you'll probably see things done with graphics 2D, but I'll just stick with graphics. It's basically the same thing, whichever one you're using, but I'll use graphics. And there's a constructor for a graphics object, but we never construct a graphics object ourselves. Okay, this is odd, but true. But if we have a graphics object, we can use any of these methods. For example, we can say draw an arc, Okay, and it'll draw an outline of an arc, circular or elliptical. We can say draw an oval, which includes drawing a circle. We can say draw a line. Okay, we can draw polygons where we have a set of points. Protected. Ooh, good question. What does protected do? It's not final, which says you can't extend. I don't know. This one I'm going to actually peek. Oh yeah, protected as in public-private. So a public method is available to any scope, right? Any class that you're writing can access a public method in another class. A private one is only accessible within the class. A protected one is accessible within the class or within other classes in the same package. Okay, and we haven't talked about packages yet, but it's kind of the default scoping. So when you write a class with a bunch of methods in it, if you have other classes in the same package, we still have to talk about packages, right? It's a collection of classes. It lets you have access inside there. So it's kind of like group in the owner group world paradigm of Unix protections. And obviously I never use that keyword, but it's useful. All right, so we can draw objects, right? 3D rectangles, which just add a highlight. They're not as exciting as they sound. We can fill ovals and polygons and rectangles, right, to fill them in with a color. We can draw a string of text, right? We can do all these cool things, but we can't just call, draw oval and make an oval appear somewhere, because draw oval is a method in the graphics class, okay? And we have to get a hold of a graphics class first. Now there is a graphics class we can use, but not in a way that we can just say, when you click this button, draw a circle. Okay, so let's see how this works. So here's my design, and there's a content pane in here. Okay, so I am going to modify this thing now. This content pane is a javax.swing.jpanel. Okay. If you look at the documentation for a JPanel, it has a method called, well, it inherits a method called paint. Paint is used to draw components, to draw stuff in your panel. Okay, and paint is called with a graphics object. Okay, so this JPanel can do painting inside this paint method, and in fact that's what makes your panel look the way it does when you run your code. Okay, when I run this, the panel part of this is this particular color, right? It has this border and so on. That's happening because something is saying, fill in this area with this shade of gray and, draw a thin black line on the outside and so on and so forth. Okay, that's set up in the paint method. Remember, we can extend classes and we can change things that are in the base class by rewriting them ourselves. We do this with toString, for example. So I'm going to create a new Java class, and I'm going to call it MyPanel. Okay, and I'm going to say that MyPanel extends JPanel. Okay, and here's one really useful hover. If I just hover over this, I can say let's import the JPanel class. Okay, what I'm doing right here, you'll do this in Android. I think you'll do this in iPhone applications. This is mostly how painting is done in modern apps. So I'm defining a class called MyPanel that extends JPanel. Okay, before I do anything else, let me just come into here. Let me look at the source code for main. And And let me look at JPanel and change it to MyPanel. Okay, so now Content Pane is not a JPanel anymore, it's a MyPanel. And down here, when I construct my Content Pane, I'm going to say New MyPanel. And MyPanel, I haven't put any stuff in here, I've just said it extends JPanel, but that's enough. When I run this, I get MyPanel. But here's the really cool thing. Since this thing that I'm going to see in here is a MyPanel, I can write code inside the MyPanel class to affect how this appears. And in particular, I can override a piece of code called Paint. Okay, so you have to import graphics from AWT, the Abstract Windowing Toolkit. But when the panel wants to be drawn, the system's going to try to call the paint method in MyPanel. Now if I don't define this, it inherits the paint method from JPanel. But if I make my own paint method, I can do whatever I want in here. So G is a graphics object, so I can say, for example, G dot fill rectangle 100, 100, 200, 200. Alright, with that one line of code, if I run my main method now, my panel has a rectangle drawn inside it. And if I shrink my window to obscure it and then I make my window big again, that rectangle reappears. So let's see what's happening here. So let's make a counter and see how many times we're calling this paint method. So I'll just bump up call number and I'll print it out before I fill that rectangle. Okay, so let's run this. We're inside paint, call number equals 1. Let me expand this. As I expand it, paint gets called a bunch of times, right? Every time this window changes size, it calls my paint method. If I shrink this, right, it'll call paint. So paint's being called a lot, right? And yes, black is the default color to fill and to draw. So let's draw a line from that 200, 200 to 300, 100. Let's do that. All right, so I've specified a 200 by 200 rectangle starting at 100, 100. Okay, let's talk coordinate systems first of all, because this is counterintuitive. At least to me it was. This is your coordinate system. Almost always when you deal with computer graphics, your origin is in the upper left. X increases to the right. Y increases going to the bottom. Why is that? I don't know for sure, but I have a theory. This is because this is how TV sets worked. Back in the 50s, they swept from the top to the bottom, right? They swept from left to right, slowly moving from top to bottom. And I think we've been stuck with that ever since, as we slowly moved from TV sets to using TV sets for displays and so on. For whatever reason, origin is always in the upper left, Y increases moving down. That will eventually seem very natural to you until you get to your linear algebra homework. But that's just the coordinate system. All right. So upper left corner is 0, 0. And this code is saying let's start a rectangle at 100, 100, so that's right here. And then this is the width and the height of the rectangle. So if you go to your graphics class and you look at your rectangle, and draw and fill will do the same thing. X, Y are the upper left corner, and then the second set of arguments are the width and the height. Alright, so our rectangle goes from 100, 100 to 300, 300, and then I said draw a line from 300, 300 to 400, 100, so that's that line right there. And I think no, okay. Can you rotate the rectangle? So rectangles are drawn exactly like this. If you wanted to do a rotated rectangle, you'd probably want to do a draw polygon and rotate it yourself, figure out the coordinates for each of the corners, and then use the draw or fill polygon method. And rotating, that gets into, you know, good old linear algebra. It's basically sines and cosines, but you can find a transformation to turn these corners into other coordinates just by, if you want, you can just do a matrix multiplication with sines and cosines and figure out the new coordinates, and then call one of the polygon methods. So polygon takes an array of points, and points are just XY coordinates. But points will be useful for us. So a point is just a simple object that has basically a pair of fields X and Y. They're integers, and it's got a few methods for like getting X, getting Y, and so on. All right. So that's the paint method. Okay. So let's interact with this. Because we saw yesterday we can pick up mouse movements, right? So let's add a mouse handler to this. So I'll come over here and I'll say add an event handler for mouse motion, and I'll do mouse moved. And over here, we know that we're going to come into this section of code. We're here because the mouse moved. Let's see, question. Are there built-in methods for doing matrix multiplication or transformations on arrays? Oh yeah, most likely. I don't know what package you want, but yeah, there's probably packages for that. But I would do it yourself anyway, because it's really fun to do. And it's really not that bad. It's a 2x2 matrix that you multiply by, but you can cobble this together by hand, and once you do it by hand, it will make a lot more sense what the matrix operations are. And I just did this for the Angry Chicken stuff that I posted on YouTube for Minecraft, so it's fresh in my brain. But yeah, but we won't have to do any rotations for what we're doing right now. But if you want to talk about that, let me know. We can talk offline. All right, so we're here in the code because the mouse moved. Let's draw a circle where the mouse is. Okay. Okay, so what's the mouse position? So we can use this argument 0, get x. And I don't need to put those in temporaries. I could just use arg0.getx directly, but I'll throw those in local variables x and y anyway. So that's the mouse position. Well, we'd like to draw a rectangle there, but guess what? We can't say draw rectangle xy 100, 100 or draw circle xy, right? Because we don't have a graphics object here. So we cannot call the draw circle or the draw oval method here. Okay? This only can be done inside MyPanel's paint method. So here's what we're gonna do, and you're gonna do this a lot. Alright, so we can't draw from here, so let's set up something so that MyPanel's paint method does what we want. So I'm going to go to MyPanel, which is called Content Pane. And I'm going to make a method called save, and I'm going to pass x and y to that so that the content pane can save the coordinates where the mouse click occurred. And in my content pane, I'm going to make a method and I'm just going to save these arguments into a pair of local variables, which are going to be class variables. Alright, so we got a really convoluted setup now, right? You're going to click the mouse is going to call this code down here, which is going to find the XY coordinates of the mouse, and then call content pane save method. Content pane save method is going to take those XY coordinates, save them in a pair of local variables, last x and last y. And what I'm going to do in my paint method is I'm going to draw an oval at last x, last y, and I'll just make it a 50 by 50 oval. Alright, well, if I run this, I get my initial oval there up at 0, 0, but moving my mouse doesn't seem to do anything until I resize. And remember, when I resize, paint is being called, right? And so if I put my mouse up here and then I resize, I get a circle up there. And if I put my mouse down here and I resize, I get a circle down here. So this paint method, remember, it was only being called when we resized the window. So even though, click the mouse, save the XY coordinates, when paint gets called, an oval will be drawn at those XY coordinates. But paint is not being called until the window is resized. So we would like to force paint to be called. Okay? We cannot call paint directly. Why? Because we have to pass it a graphics object, and we don't have a graphics object. So here's what we do. We call the repaint method. And repaint is a way to say I would like the paint method to be called. It does not call it right away, but it issues a request to say, hey, when you have a chance, call paint. And once I've called repaint, at some point the system will call paint, which will cause this code to run, which will cause an oval to be drawn at last x, last y, which were saved here when I passed the coordinates of the mouse. So with that one call to repaint, now I have something that is drawing a circle wherever I put my mouse. And you can have fun with that. And you can see how fast you can move. Alright. So that's kind of cool. Alright, I'll use that for my splash screen for the video. All right, so lots of parts and pieces here, right? Ask questions if this is not clear because it's a bunch of moving parts. Mouse click fires this code, gets the XY coordinates, calls save. Saves those into these local variables, and then repaint says please call the paint method for me. Eventually paint gets called, and paint uses those saved X and Y to say where should I draw the circle. Okay, so how is the oval being drawn if we never call MyPanel's paint method? Because we call MyPanel's repaint method. And repaint says, hey, call MyPanel's paint method when you have a chance. The thing is, we don't get to actually call paint because it's scheduled with a whole bunch of other things. It's asynchronous. Okay? If I resize the window, it will register a request saying, hey, the window got resized. Please call paint when you can. Okay, so we're adding our hat in the mix. We're saying, hey, yeah, please call paint as soon as you can. And then the system calls paint. Do we ever declare a graphics object? Probably not. You can, but even if you can get that to work, it's not really the right way to do things. The issue is that painting on your display is a really complex, error-prone process, right? Lots of things are trying to write your display, and it's controlled through, in the swing class, there's a central place that's managing all of that. If you make a graphics object to somehow get a hold of your display area, then you may have multiple things painting at the same time, and you're going to end up with them fighting with each other. So we don't usually make a graphics object ourselves. We simply put our drawing inside Paint and use Paint's graphics object. Alright, this is good. We got lots of questions coming. Is there an on-mouse moved function in JPanel we can override without having to add an event listener? I believe so. So for some of these events, you can actually override the method, or you can add a listener. And the way I'm doing this is by adding a listener. But yeah, in some cases, and especially in Android, you can override those methods. The trick is, if you're going to take the override approach, usually it requires you to override all of the methods that are in there. So if we want to do mouse motion, we'd have to make our own mouse motion, but also a mouse click and a mouse drag and all these other things. So adding the listeners is usually more straightforward. Alright, how do we avoid the initial oval in the top left? Well, that's a good question. So I could do something like this. Right, I could set valid equal to false, and the first time you say save, I could say valid equals true, and then in my paint method I could say if not valid, let's just return. And now when I run, I don't get that initial oval in the top left, right? It'll actually pop up the first time my mouse appears somewhere. So you can flag it like that. Okay, is repaint a JPanel method? It's a method probably of a component. But let's make sure. So yeah, the repaint we're calling is probably the one from JComponent, right? And adds a specified region to the dirty region list if the component is showing. The component will be repainted after all the currently pending events have been dispatched, right? So we're really just saying, hey, this needs to be redrawn. Do this when you can. All right, is the mouse click event named arg0 pretty arbitrary? Yes, absolutely. So I can come in here and right, I could call this haha, and that's just as fine. Let's see, is repaint guaranteed to be called before the window gets constructed? It's called, so paint is called as part of the window construction. Okay, it will be called at least once. It may be called more than once. But we can come in here and let's put back our our print method. And say inside paint. And so the first time that I run this, paint got called exactly once. Okay, so, and it may get called more than once. That's also possible. Okay, can you change the colors of the oval so we get a cool rainbow effect? Absolutely. Is paint similar to two-string where it gets called automatically? We'll go back to the rainbow in a second. Paint is called by Repaint, and Repaint is called automatically when, for example, you create a window, when a window gets partially covered up, when it gets resized, things like that. Basically, any time that it might need to be redrawn, something we'll call Repaint. We're really kind of tricking it here. We haven't obscured the window, but we've changed what the window is going to do. So we're saying, yeah, the window needs to be redrawn. And then the next time it paints it, it'll do something different. It'll do what we want. All right, so let's go back to the graphics class. And so there's a set color. Alright, so we can set the graphics context, set color. Set the graphic context current color to the specified color. So, so let's try that. So in our paint method, we will say g.setColor. Let's just say color.red. Okay, so color is another class. So let's try this. Alright, so we got red ovals here. So if we look at the color class, it's got a bunch of static fields, okay, both with upper and lowercase letters for convenience. So, you know, color.red is just a static color of type red, but we can also construct a color, and we can construct with floating point or integer RGB. This is sort of the oldest model of making colors. It's a mix of red, green, and blue. Those are the three colors of light that you mix to get all your colors. With paint, it's different. So we can specify the amount of red, green, and blue, and set the color like that by constructing a new color. So, so let's do this. Let's set up some default colors, and let's do the following. Let's increase red by 5, green will increase by 10, and blue will increase by 20. And colors have to go from, the red, green, blue components have to go from 0 to 255, so I'm just going to mod them by 256. So all I'm doing here is I'm just kind of like randomly changing the colors. I'm just adding a little bit to each color and making sure it doesn't go beyond 255. And And then we're going to use those to set the color. And it doesn't like G for some reason, though, because G is our graphics. So we'll call it GR for green. Alright. So if we do this, every time that we do paint, the colors are going to change slightly. Right? And it'll take a bunch of moves before these colors change a lot. But just to get an idea, right? So now we get the cool rainbow effect. I know setting R, G, or B to the X, Y values produces a cool effect too. Oh, that is cool. Yeah, it is a slinky. And so you can totally play with this stuff. So we can set red to, I guess this should be last X, to the X position. We can set green to the Y position. We can set blue to the some of the X and Y positions. And we'll get something totally different there. So you can play with this like all day, right? Or several days. So that's fun by itself, right? Okay, so here's the bummer. What we're doing is actually not technically correct. Okay, we're actually taking advantage of a bug in the code that we've written. And we can see this bug as follows, right? We can do all of this really cool drawing, but notice what happens when I resize the window a little bit. All of it goes away except for one oval. And that one oval is wherever my mouse position last was, and when I resize the window, everything goes away again. Okay? Our paint method should not be drawing slinkies. Our paint method doesn't say draw a bunch of ovals, it says draw one oval. But when we run this, we're seeing a whole bunch of ovals. We're seeing the remnants of previous calls to paint. Okay? This is actually a bug in our code. Because really what we should do in our paint method is the first thing is we should clear the entire panel. And then we should go ahead and draw an oval. Okay, we're not clearing the panel, we're leaving whatever was already drawn already up there. And most of the time that will give us this persistent effect, but it's really not a proper use of painting. Okay, oh, that looks really cool. It's a kind of anomaly that happens to look cool in this case. So what we want to do is we want to reset the panel to an empty drawing area before we do anything else. Okay, and if we use the default paint method, that's exactly what it does. It clears the area, it draws the background in this uniform gray color, it sets up the border, things like that. We still want to do that, okay? Even though it'll make the cool slinkies go away, to really make a proper paint method, we need to make sure we do the proper initialization. I don't want to write code in here to clear the background, set to default background color, display borders, etc. We want to do all that stuff. I don't want to write code for that. So what are we going to do? We're going to use the default paint method to do all of that stuff. How do we get to the default paint method? That's where we use the super keyword, right? So I'm going to call the super class's paint method with an argument of G. So we're calling the JFrames paint method here. That's going to clear out the display, set the background color, start with an empty slate, and then I should end up drawing just one oval. And so if I do that, I've got a moving oval that changes color, right? But it's really just one oval. And that's a properly written paint class now. All right, so there's a lot of concepts we've gotten through already, right? There's this idea of when the mouse event happens, we can't paint. So we save some information and say, hey, call the paint method in MyPanel. And the paint method in MyPanel uses that saved information to do something. Okay. There's the idea of calling the super classes paint, okay, the JFrames paint, to reset the background. There's manipulating the color, which we can do a lot of different ways. There's the actual draw method. Okay, it's just a few lines of code, but there's a ton of concepts going on here. So lots of stuff to sort of squeeze into our brains. Now what if I wanted the slinky-like behavior even though I'm clearing the background? Well, I have to save all of these previous mouse positions and draw all of those previous mouse positions. And we have 7 minutes, and that might be enough time to do that. So the keyword super calls the original pre-built paint. Exactly. Yep, that's exactly what it does. So since this extends JPanel, super basically refers to the JPanel's paint method, right? Which is still available. It's just that when you call paint inside of MyPanel, it's going to run this code. Okay, but if I do super.paint, then it calls the paint method that we overrode. Yeah, you're welcome. Alright, I probably won't finish this in time, but let's try this. So let's pull in our point. Let's pull in our linked list class. And let's pull in our point class, and let's save our XY coordinates in this linked list. So our save method if you extend your MyPanel and create another paint, would you do super.super.paint? That's a good question. I don't know. I've never tried that. That makes sense, though. Give it a shot, because everything's usually an extension of multiple things. See if super works. Well, we can try it right here. Doesn't seem to like that. Super duper paint might work, yeah. But you could make something in the previous class called, you know, paint 2, and that could run its super's paint. There may be a built-in way to do it too. All right, so let's make this point P, and let's add this to our points. So points.add P. So now we're building a linked list. We're going to run out of memory pretty quickly. We're building a linked list of all of the points. And in my method here, here's what I'm going to do. So go through all of the points in our linked list. I'm just going to call the get method. On my linked list, I'm going to get the ith element, and there should be a get x. Let me check the point method. Alright, get x returns a double. So is there a for each for linked list? Yes, there is. I don't know it off the top of my head, but there's a way to iterate through, and that would work here also. So let's just go through all of the elements in our linked list, pull out the x and y coordinates of that point. I'm just saving them in last x, last y, so I'm not using last x, last y the same anymore. And then we'll do the usual, set the color and draw the oval based on that. So now if I run this, right, there we go. Now I'm building a really big linked list while I'm doing this. And I'll run out of memory pretty quickly. Not as quickly as I thought, right? But what could we do? We could turn this list into a queue or a stack, right? And only keep, say, the last 100 points that we've put in this linked list. And if we have 101st, we could delete the first one, right? And then we'd get a moving snake that would follow us around, and have a fixed length of, say, 100 circles, and then our memory would be spared. So these are the kinds of things that you're going to encounter in PA4. This kind of stuff we're going to be doing in our paint method. Okay, it's going to be whatever you need to do to make the display look like you want it to look like, which will usually be more than just drawing an oval or a line. It's going to be going through a data structure you've built in memory, right? A linked list, an array, a two-dimensional array, something like that, and issuing draw commands on the graphics object in response to what you've stored in memory. Okay, so that gets us started, at least, with this idea of graphics. So we'll talk about PA4 tomorrow, and then we're going to have to start digging into a lot of details of how we do certain manipulations in graphics. So how do we translate mouse coordinates to objects on the screen and things like that. So we'll continue this tomorrow. All right, have a great afternoon.